Hello, everyone. I am going to just briefly go over tomorrow's severe weather event for um, central South Carolina, central North Carolina, and along the along the coastal regions. The setup for tomorrow is very similar in some ways as last week, but there are a few uncertainties going into the system that could limit the potential of more widespread severe event. So we'll have to just keep an eye on that, and I will go over that here shortly. So first, I just want to start with the NAM 3K model here, and I just want to just see what the potential radar could look like. Just see what it's showing here. So we see the potential tornado outbreak happening to our direct west in the deep south across Mississippi and Alabama today. Um, this this is this evening. This is by tonight. We can see that main line start pushing east, and by Sunday morning, we can see this line of convection approaching central South Carolina and into central North Carolina. Um, as we move on, afternoon, we can see the potential for scattered uh, thunderstorms to develop along the coast, along central South Carolina, North Carolina, throughout the afternoon. This is Sunday around 3 p.m., 2 to 3 p.m. And by Sunday night, um, by like 11, 12 o'clock, everything should be moved out of the region, according to the NAM. Well, let's compare this to the HRRR model. This model normally does better with sometimes it can be a little too convective, meaning it can show maybe uh, too many storms. But this is usually the go-to model for severe weather, so let's just see what this says. So as we're going through the afternoon today, you can see that line of storms move eastward. This is Sunday morning. It is a little faster. The HRR is a little faster with this line of convection. It's already in central South Carolina and North Carolina as the NAM. This is Sunday 12Z. As the NAM here was just slightly further west to the HRR. But as we go on to the morning, the HRR shows that line of convection. So, oh, sorry. Some nice little cells popping up on this HRR run here. You can see that very thin. There's going to be a very thin, very isolated area, thin kind of area um, of development of more prime conditions for thunderstorm development compared to maybe along the coast or further inland. We may have more. We're going to have more daytime heating across the central portions of South Carolina and the coastal portions of South Carolina up towards central North Carolina, towards the coast. We're going to have a lot more daytime heating, a lot more instability, um, moisture present at this time. Um, however, you know, the wind shear, the winds in the atmosphere may be so strong that some of these storms may actually have trouble um, actually really developing to their full potential. But we can see the main threat time is really Sunday morning, 7 a.m., 6, 7 a.m., all the way through all the way through Sunday, 12 o'clock. There, some places could have a few rounds of strong storms, maybe severe storms. Um, let's look at a few soundings. This is just a vertical kind of representation of what's going on in the atmosphere. Let's look at a few soundings here at both models, just to see what they're looking at. So this, I'm going to take this closer to central South Carolina. We can see a pretty nicely shaped clockwise photograph here. Um, that's representing the turning in the winds. We can see, zoom in here, 1 kilometer up, 2 kilometers up, 3 kilometers up here. And we can see how the turning of the winds are clockwise. And we can also see this right here as the winds coming straight from the south and they start shifting from the southwest. So they are turning clockwise as we go up in the atmosphere. Zoom out a little bit here. As we go up, we can see 1 kilometer, 3 kilometers, 6, and it's turning up as we go. Another thing I noticed is we have around 1,000 surface cape. Um, most unstable cape is above 1,000. We can see this, and it goes up pretty far. The equilibrium level is pretty far up there, almost 12 kilometers up. This thin layer of cape here is present. 3 cape is 63 right here. Usually, if you want enough vorticity on the surface to turn those winds, you need your 3 cape to be around 100 or higher for tornadoes. So to favor tornadoes. But yeah, this photograph is very it's kinematically supporting the threat for tornadoes. And then we have our thin layer of instability in between the white dash line and your solid red line, all the way up to about 12 kilometers. So we have enough. We just have just enough instability. It looks like possibly, and this is for about 11 a.m. Central South Carolina. Let's take a sounding. Let's take a sounding further north here, just around maybe the Fayetteville region. We can see the clockwise photograph here, and we can see our not a whole lot of cape here at this point. Let's go a few hours ahead. This is around the Fayetteville region, and then we can see here. Yeah, again, the clockwise photograph looking good. More cape, more instability. Not a whole lot compared to Central South Carolina, but still enough with the impressive kinematics with this event. Let me take a sounding of the Grand Strand region here, and we can see again. Let me go back one. All right, we can see here. Again, we have a nice curved photograph here. We can see some nice mid-level, some decent mid-level cape instability cape. Not a whole lot. This doesn't look too impressive, thermodynamic wise, and I think that's going to be the issue with this setup. Central SC and NC into the coastal regions is instability. We won't have. I don't think we're going to have enough time for that daylight or daytime heating to really kick in, and I think there's going to be quite a bit of cloud cover in the region too, and we'll look at that um, here shortly. Let's look at some of the soundings on the NAM just real quick. I'll just take a few. Um, Central South Carolina, as that first line is approaching. Again, it's showing that nice curved photograph. Let me go an hour ahead here just to see. But yeah, the NAM is just it's not really it's not as thermodynamically heavy as the HRRR. So it's definitely, with this event being 1 day out and having model discrepancy like that, it's just um, leaves a big question mark. It's do we get around 1,000 joules per kilogram of cape, or do we get closer to 300 or 400? And that 600, 700 increase will certainly mean uh, the difference between an isolated event to a more scattered severe event. So it's just very important to pay attention to that, and we'll get into what the model said there. Right now, I just want to look at the dew points, what the forecasted dew points are projected to be. Okay, so expect some muggy conditions, uh, especially if that sun comes out across central South Carolina, North Carolina, and the coast. We'll have some low 60 dew points. Humidity will be uh, fairly high as well. But we can see our cold front right here, the sharp cutoff of the blue and the green right here. We can see this is where our cold front is. And as we move on, you can see that cold front approach. And we can see this is a Sunday around 12 o'clock, and we can see mid 60 dew points all the way up across really central Virginia here. Enough moisture to work with here. I don't think, these storms are gonna have enough moisture to work with. HRRR, we'll just quickly look at this. Yeah. As we go out through, this is, oh, excuse me. This is Sunday afternoon. We can see HRRR is definitely more aggressive with these dew points having um, upper 60s possible across central SC and NC, and even the coast having mid 60s. Uh, Definitely enough. And even these mid 60s surge all the way up into Virginia and even parts of Maryland and Delaware. Um, that is certainly impressive. Let's look at the cloud cover real quick. This is the HRRR still. Okay, Sunday morning. Okay, this is Sunday morning. Around 7 o'clock, we can see some sun. According to the HRRR, we can see some sun peeking through towards the coastal regions of South Carolina and southeastern North Carolina. That seems to last for a few hours. Could that be enough to? Is this the reason why the HRRR is maybe more, um, say, aggressive with the convection? Possibly. But we could see a few hours of maybe off and on sun that could be just enough to create, just enough cape of around that 1,000 joules per kilogram range, just enough to give extra juice to these storms. Um, let's see what the NAM 3K is saying here. Okay, Sunday morning. Yeah, it's very heavy on the clouds compared to the H4. It's more favoring the cloud cover with very little breaks at all. Maybe a few in the early morning. You can see those darker shades, but still nothing compared to the H4. And that's probably why, right there, the reason why the H4 is more convective, more um, showing more of that scattered severe event. So very interesting. I overall, this event's going to be very isolated. I feel like there's a few things that are just um, a few things that are going to be in place that will make this event possibly fail, and that's not necessarily a bad thing. So right here, um, this is from the Wilmington, North Carolina National Weather Service, and this is detailing that morning convection that I had mentioned, moving through central South Carolina, North Carolina around 7 to 8 a.m. Sunday. They mention here that um, if that were to happen, cloud cover and shower outflow will dampen low-level lapse rates, and even as warm air advection and insulation produce a limited quantity of elevated instability. Meaning, if this convection were to be, um, associated with those heavy clouds and a lot more rain, maybe than what the models are showing, it could have impacts on our severe weather system tomorrow. Essentially, not fully. It's still a non-zero threat, but really eliminating most of your increased wind damage threat, and possible isolated tornado threat. It also says here, and I had mentioned this too, with the strong kinematic field ahead of the main line, um, that some of these storms that do form will struggle to maintain vertical organization, essentially just fall flat on itself, um, and it won't reach it won't reach the potential max that it could reach in the conditions. And here's the overall risk threat. We can see the slight risk from the Florida Panhandle all the way up to the West Virginia uh, Panhandle region, up to Maryland. So very broad area or tornado risk here of 5% in the brown. Central Virginia all the way down to southern South Carolina has that potential to see a quick spin up. Especially, I'd pay attention, especially if that convection isn't as bad in the morning. I'd pay attention to um, zoom in here. I'd pay attention to maybe this sort of region right in through here, kind of central NC, central South Carolina. That would probably be the most favorable. Of course, quick spin up through here, just with the kinematic and the dew points up mid 60s and the strong kinematics. You're going to have a quick spin up threat up there in central Virginia as well. Look at our wind threat here. We have a broad 15% risk, and then our hail threat as well, around the same as the wind essentially. So this event will be low impact. I'm not expecting much, but do be weather aware tomorrow. A strong wind gust, 60, 65 miles per hour and quarter-sized hail, certainly possible with any stronger storm and a quick tornado. With any maintained structured supercell that may form, especially ahead of that line. So just be weather aware. It's a non-zero threat for sure. Hopefully by tonight the models are in a more agreement, and we can have a better forecast by early tomorrow morning for tomorrow's threat. Um, but I'd assume this will stay a slight risk event, and 65 mile per hour winds and quarter size hail with a quick tornado or two is likely. So if you have any questions, let me know. And until then, see you guys later.